Hey everyone, welcome back to the channel Code with AKJ. Today is day 16 of solving GFG problem of the day. Today's question is sorted subsequence of size 3. So the question says you are given an array ARR, you need to find any three elements in it such that array of I less than array of j less than array of k and I less than j less than k. We have given three note and the note is output will be 1 if the subsequence returned by the function is present in the array. If the subsequence is not present in the array, then return an empty array. If the subsequence returned by the function is not in the format as mentioned, then output will be 1. So the summary of this problem statement would be to find any three elements in this array such that array of I less than array of j less than array of k, and we need to make sure that these indices should be less than each other. Now the output will be 1 if a subsequence is present in the array. If the subsequence doesn't exist, we'll return an empty array, and lastly, if the subsequence returned by the function isn't in the correct format, it will be -1. So let's analyze this input array. I've written here, and we need to find any three elements in this array such that values should be less than each other. Same goes with indices. So the brute force approach here could be to run three loops and take three different pointers and compare each and every array element with it such that this particular condition satisfies. So here I initially starts from 0, j starts from I plus 1, k starts from j plus 1, and we'll compare these three indices values with each other. So let's try run this. K starts from 2 here. So let's compare these three index values. So 1 less than 2 less than 1, is it satisfying this particular condition? No. So we return false here. So we'll move k from 2 to 3. Now let's compare this. 1 less than 2 less than 1. No. So we return false. So we'll move k from 3 to 4. So let's compare 1 less than 2, 2 less than 3. Yes. So we return true. So hence we found a triplet in this array which satisfies this particular condition. Same with this condition of indices. So we'll return this particular triplet in the form of vector from the main function. So let's code this approach and see whether it gets submitted or not. This is the code of the brute force approach we have discussed earlier. So I have taken the size of an array. I have used three for loops with three different indices which runs from 0, I plus 1 and j plus 1, and we'll compare this particular condition whether it gets satisfied or not. If it satisfies, we'll return there and there itself. If not, after finishing all these three for loops, if we didn't find any triplets from the array, we'll return an empty array at the end of the function. So let's submit this code. So let's submit. As this problem solved successfully and submitted successfully, the time complexity of this code would be O of n cube as we are using three for loops, and space complexity would be O of 1. But the expected time complexity they are asking should be O of n, and space complexity we can use at max would be O of n. So let's try to optimize this approach. Now let's move on to a more optimal solution. We can solve this particular problem in O of n time complexity and O of n space complexity. The idea here is to maintain two auxiliary arrays where we'll find the left min values of each particular index and right max value of each particular element. It generally helps us to identify smallest and largest elements on either side of a element in the array. So here the left min array keeps track of the smallest element to the left of each element in the array. The same with the right max array. Then we just check each element in the array to see if there's a valid triplet using these auxiliary arrays. In this way, we can reduce time complexity from O of n cube to O of n, and as we are using an extra space, the space complexity here would be O of n. So let's try run this approach with an example and let's check out the code later. So here I have taken the array 1 to 113. So let's fill this left minimum array. As 1 is the starting element of the array, we need to store the int max value, which is the highest value, as there's nothing to compare behind it. So in the same way, for the index value 1 and the value 2, we'll compare the values from minus 1 to 0 to its left side and find out the minimum value from it, and we'll store that particular value at that particular index 1. So here the answer would be 1, as 1 is the minimum element behind it, and for the index and for the value 1, the minimum value would be 1, and same goes with all the elements further. In the case of right max values, we'll start from 0. So we'll find out the maximum value from I plus 1 to n, and since in this case the maximum value would be 3, so we'll store 3. The same goes with all the values till n minus 1. In case of the end element of this particular array, there's no element to compare and find out the maximum value, so we'll store int min value at the end of this array. So after finding these two auxiliary spaces, left min and right max values, we'll compare each and every element with these left min and right max values and check whether we find any triplet in this array. So we'll iterate from 1, as we need elements from both behind and front, and we'll take these values. So at I is equals to 1, the value would be 2, and at I is equals to 1, the left main value will be 1 and right main value will be 3. So 1 less than 2 and 2 less than 3. So these three values satisfy the condition, and hence we found a triplet in this array, and we'll return this value from the main function. So let's analyze one more example, and let's move on to the code. Here the left main and right max value arrays would be int max 1 1, and this would be 5 and int min. So as we start from I is equals to 1, the condition would not satisfy, as this equation is not valid. The same goes with the iteration 2, as this condition is not getting satisfied. So hence after iterating all this particular array, we are not getting any kind of triplet, so we return 0 from this array. So let's move on to the code and see whether it gets submitted or not. So this is the code of the optimized approach we have discussed through two examples. I have taken the size of an array and stored it in variable n. This would be the base case, as if the size of an array is less than 3, we'll return an empty array, as we cannot find the triplet. And I've taken two arrays of size n. First I've filled the left main array and stored the int max value at the initial element, and store the int min value at the end element of the right max array. We have iterated over the array and filled the array with left main values, the same with right max values. And finally we found the triplet using this for loop. We checked with this particular index condition, and we finally return in the form of vector. And after completing this particular for loop, if we didn't found any kind of triplet in the array, we'll return an empty array at the end of the main function. So let's compile and run. It's working. Let's submit. It's getting submitted successfully. So the time complexity and space complexity is being optimized as expected from the given problem statement. So this is it, guys. I hope you liked my explanation and this particular video. So if so, please give it a like, share it to your friends, and subscribe to my channel. Thank you. I'll see you in the next one.